Okay, starting out today, I want to take a look at this function. And some of you just clammed up because you said, oh, it looks like a piecewise function. I hate those, and that's fine. But it's a little bit different than a piecewise function. Don't get me started on piecewise functions, because I think we have a lot of people that don't teach piecewise functions the way I think they should be taught. They start with something that looks like this instead of starting with a graph of real data that they need to describe and make predictions for and come up with functions and on and on and on. But I'm a little bit different. Okay, this function's a little different in that it's called a recursive function. And the reason it's called a recursive function, as you see, one of its cases calls the function again and wants you to redo it. So I have a problem to start here. F of x, it's x squared plus 1, and when x is less than 3, 2 times f of x minus 1 plus 3 when it's between 3 and less than 5. And when it's greater than 5, it becomes f of x minus 1 plus 6. So if I said to you, what is f of 8? Do you think you could come up with the answer? Some of you have paper and pencil and you're already working on it. We could have a race, but I couldn't say who won because I don't have the answer yet. But let's see, I want to calculate f of 8. And f of 8 is going to fall in this third line. It's going to fall in the domain value of x, and it's going to display, well, that's going to equal f of 7 plus 6. What is f of 7? I don't know, but I need to add 6 to it. All right, so now I'm going to go and reinvent my problem, and it's getting smaller. F of 7 stays with this third line. It equals f of 6 plus 6, which is something plus 6, which I don't know what that is. F of 6 is going to equal f of 5 plus 6, and I don't know what that is. So I'm starting to go down this rabbit hole where I can't finish this until I get the value of f of 7, but I can't finish that till I get f of 6, and I can't finish that until I get f of 5, which becomes still in here, f of 4 plus 6. So now I need to find f of 4. F of 4 is going to fall in this third range. It's going to equal 2 times f of 3 plus 3. Well, I now need to find f of 3. Notice how I paused? That was because some of you are actually trying this on your own. And A, you either need to catch up, or B, you got really excited and you wanted to find the answer before I do. F of 3 falls into that group. 2 times f of 2 plus 3. Oh, I put that there. So I'm really slowing down now. F of 2 equals 5. So I plug that back up here. 2 times 5 plus 3 is 13. So now I'm coming back out of the rabbit hole. And now I know f of 3, that becomes 2 times 13 plus 3, which is 29. Coming back out of the rabbit hole, 29, that gives me 35. 35, that gives me 41. It's good, I'm good at adding 6. 47, 53. So f of 8 equals 53. 53. Anybody else get that? I see a couple of yeses. Oh, Mayan is here. Yay. Spencer, are you here? Spencer's here, yes. Mayan's here. Good. David, you're here, right? No, CJ, are you
I'm
here?
here.
CJ, are you here? No CJ, no Yug. Okay.
And
yeah, who was that?
no Alex, right?
And no Alex. Yeah, Alex isn't here yet. Oh yeah, he is. There he is. Cool. Done with attendance. All right.
Damn, I almost missed. I almost
Yeah.
missed this class.
I know. That would have messed up your perfect attendance. I didn't like it. So this
Yeah,
idea,
sorry, I slept a little later than usual today, and I kind of
did you stay up watching the Eagles like I did?
I'm not really a sports guy, so no.
You're missing out, I'll tell you. All right, so this idea is called recursion. And it's a function that, as you saw on the last page, is it's going to call itself. A couple of code listings you started to look at. 20.1 was a brief introduction. 20.2 was actually pretty good because in the method, it had as it comes back out of the rabbit hole, it starts printing out this message. So you went down 5, 4, 3, 2, 1, all the way to 0. And as it started coming back out, you got the 0, 1, 2, 3, 4, and 5. That would be like the problem we did on the last page, displaying each answer after we went down as we're coming back out. So as we're coming back out, it would have been once I found this 5, then I would have displayed the current total was 13, the current total is 29, and I would be displaying each one of these as I came back out of the rabbit hole, as I like to call it. Okay. So what is a recursive function? It's one that can be solved if you can take the problem and break it down into something that is similar to what you've been doing. Okay. One thing is you can always do these with a loop instead of a recursive method. Okay, so you can always do them with the loop. Why do recursion? Well, sometimes it's cleaner. Is it more efficient? Usually not programming time wise, but as I said, sometimes you look at it and it's going to be some cleaner code. Another code listing you typed in was 20-3, and this was kind of a good one. It was simply to do, let's see, I was doing factorial, right? So I'm taking, and I know to do factorial, it's going to be 4 times whatever 3 factorial is. And that's 3 times whatever 2 factorial is. And that's 2 times whatever 1 factorial is, which is 1. So I come back out, 2 times 1 is 2, pass that back up, I get 6, pass that back up, and I get 24. So this recursive call keeps taking me down to 3, to 2, to 1. When I get down, well, they go all the way to 0. When they get to 0, it returns 1, which sends it back to the previous method call, and we work our way back out of the rabbit hole. As you can see, we have a base case and a recursive case. The recursive case is the one that calls the method again, uses the name to call the method. In the math example we did on the previous page, we had a base case. When x was less than 3, I would be returning x squared plus 1. I also had 2 recursive cases in this problem because this one calls the function again. This one also called the function again. If you take CPS 230, we will do a bunch of work with recursion, working with problems like this to really train you to understand how to do recursiveness. I don't know if that's a word, but I use that. Okay. Little note there with the recursive case. It does, in fact, reduce the problem to something smaller. A couple of code listings I had you look at that are worth pointing out. 20.5. Haha. So way back when some of you had me in 121, you knew you may have to write a method to do the greatest common factor or the greatest common divisor. And here's an example of that method. We're bringing into, let me get there. I can't. But you've seen it. We've talked before about using the Euclidean method in one of our problems. And some students actually did this in 121. They got this, they memorized it, they made the method. but the Euclidean method, it has a base case where I return y, has a recursive case. So now the question is, you're going, oh, that's awesome, that's great. But my comment is, how do you do the Euclidean method? Ha, ha, ha. So let's see, I want to find the greatest common factor. I'm going to take a look at two numbers. Greatest common factor of, let's see, I'll make it easy, 24 and 40. 24 and 40. So if I got ready and took a look at this and I said, show me you understand what the Euclidean method does. So I call the method, they call it GCD instead of GCF. So I'm going to switch this, GCD. What would my next call be in GCD? What are the next two numbers that I would send in?
Would it be 12 and 20?
I hear one suggestion of 12 and 20. I'm thinking more along the lines of one of these two numbers is going to go in.
24 and 16.
I hear a 24 and a 16. And where does the 16 come from?
I think it's 40 divided by 24 and whatever the remainder is.
Okay, so modulus does in fact give us the remainder. And it would in fact send in 24 and 16. Do we buy that? Well, let's see, my little method was if x mod y equals 0, if that's the case, I return y. Else, return, and this is my call, return GCD of y, comma, x mod y. So let's see, x, what's the remainder when 24, oh, I'm tilted. When 24 is divided by 40, it goes in let me ask you this. If I said 24/40, what do you get? Say 0.
0 with a remainder of 24.
0. And if I did 24 mod 40, I would get 24. Okay. So actually this first one is going to say to call GCD of my y value, which was 40, and my modulus, my remainder, which is 24. So what happened there is all it did basically is switch those two values. And that's okay. Now, my next call is going to be my y value, which is 24, and what's the remainder of 40 mod 24? Now it's the 16. Okay, now it's the 16. So it actually did something really nice for us in that we didn't have to check to see which one was the highest to put the highest first. The first time through, it switched them around and made my highest become first. Okay, this time I'm gonna do GCD. Right now, 24 mod 16. No, it doesn't go into it evenly. So I'm going to call it again, 16 and 16 goes into 20 and 8, right? And 8. Now if 16 mod, does 16 divide evenly by 8? The
Yes.
answer is yes. Winner, winner, chicken dinner. So my 8 should come out. So it's great that you all probably typed that code in for code listing 20-5, and ooh, it worked. And look, it's cute. But did you really understand it when you went through it? And now that you went through it, are you sort of like, okay, yeah, that was kind of worth looking at. Hopefully that's the case. Give me the okay, Melissa. Okay, she was copying it. I wanted to give her a minute. All right. The next code listing was 20-6. And this one was working with the Fibonacci sequence. Okay. And again, we talked about the Fibonacci sequence. It looks like this one starts at 0 and 1, other 1 and so on and so on. But I want to build the first 10 numbers of the Fibonacci sequence. And it goes 0, 1, 1, 2, 3, 5, 8, 13, 24. Do you notice how I'm returning the one before plus the 1, 2 before it each time? So this one doesn't come out as clean and easy, but I bet if you had some test data and you walk through it, you'd be going, oh, okay, let's see what's going on. So what do I have? I have a nice, so we're going to do, in this case, 10 for the first 10 numbers. I don't know why I'm at, there we go. And I'm looking at if n is less than or equal to 0, I return 0. If n equals, that's an else, excuse me, I'm just jotting this down quickly. N equals 1, I return 1, else I return fib n minus 1 plus fib n minus 2. Okay, so let's see if we can follow this. I want f of 10 or fib of 10. I'm just going to say f of 10. Fib of 10 equals what? Fib of
9 plus fib of 8.
Fib of 9 plus fib of 8, which I don't know what either one of those are. Fib of 9. So this is kind of following along with the algebra from earlier. Fib of 9 equals fib of 8 plus fib of 7. 7 equals fib of, oh boy, I need 8 first, excuse me. Fib of 8 equals fib of 7 plus fib of 6. Fib of 7, I'm really chicken scratching this because I'm going through quickly because it's like a pattern. 7 equals 6 and 5. F of 6 equals 5 and 4. F of 4, 3 plus F of 2. Starting to get somewhere. F of 3 equals F of 2 plus F of 1. F of 2 equals F of 1 plus F of 0. F of 1, I know what that is. What is F of 1?
1.
F of 0.
0.
0.
Okay, so I know F of 2 equals 1. F of 1, we said equaled 1. F of 0 equals 0. So if I'm displaying these like they are, we're going backwards. Now I know F of 2. F of 2 is 1. F of 1 was 1. So F of 3 becomes 2. F of 3 is 2. F of 2 was 1. That's 3. I didn't do F of 5. Oh, crap. F of 5 equals F of 4 plus F of 3. That's going to give me 3 and 2 is 5. This is 5 and 4, so that's 5 and 3 is 8. This is 6 and 5, so that's 8 and 5, which is 13. This is 7 and 6, 21. 8 and 7, 34. 9 and 8, 55. So one of the things that you're going to start to do as you keep programming and programming is more and more of this paperwork, where you need to be figuring out a whole bunch of math before you even get started in trying to figure out what the code is. But I want you to figure out what the code is. So I have two problems. First one is that problem from the beginning of class. I want you to write a program that solves that. And then I also want you to do a second one that finds the sum of the numbers from 1 to n. So if the user inputs 10, it should display 55. Is that correct? Do we all know what the sum of the numbers from 1 to 10 is? So if the user inputs n, you have to figure, what's the shortcut formula? Where's some of my pre-calc students? The sum of the numbers from 1 to n. What's the formula? I don't want you using the formula. I want you to use a recursive function. What's the formula? Anybody? Bueller.
N plus 1, choose 2.
N times n plus 1 divided by 2. That goes back to where you do the 1 plus 2 plus all the way out to n, and then you do the n plus n minus 1 all the way down to 1, and then you add these together, and there's n of the n plus 1s, but you had 2 rows, so you have to divide it by 2. Matthew, I don't know if your formula is the same as well, but this is the one I remember. N times n plus 1 over 2. We take the row, we reverse it. All of these add up to n plus 1. There's n of them, but then I had 2 rows, so I have to divide it by 2. So I want you to do recursive functions for finding the sum of the numbers from 1 to n and the problem from the start of class.